Hi dear students, welcome to Vidyavardhini Academy. In this video, we are discussing balancing of redox reaction by using oxidation number method. Okay, and here the equation which is given. The first method which we are supposed to follow is writing the equation. It is already done. Then calculate the oxidation number of the element which undergoes oxidation and reduction. Okay. In KMnO4, the element which undergoes oxidation is manganese, and when you calculate oxidation state, let us take KMnO4, manganese we need to calculate, potassium is alkali metal, hence the oxidation state is +1, manganese I will take it as X, plus oxygen, there are 4 oxygen atoms, each oxygen -2, hence 4 into -2 equals to 0. Therefore, X equals to +7. Here the oxidation state of manganese is +7. Next, coming to FeSO4. In ferrous sulfate, ferrous is +2 oxidation state. Now here iron, ferric sulfate. Ferric means it is +3 oxidation state. And here in the product side we have MnSO4 where manganese oxidation state is +2. And clearly we can see that KMnO4 in which manganese is changing from +7 to +2, there is a decrease in the oxidation number which we call as reduction, and in case of iron there is increase in the oxidation number from +2 to +3 which we call it as oxidation. The second step is, after once we identify the oxidation numbers, the second step is writing the equations separately. Now I will be writing oxidation reaction and reduction reaction separately. KMnO4 changes to MnSO4. MnSO4. And here the oxidation state is +7 and it changes to +2. This is our reduction reaction. Similarly, I will write oxidation reaction, that is FeSO4 changes to Fe2SO4 thrice. Okay, and oxidation number changes from +2 to +3. First step in this is identify first whether the element which is undergoing oxidation and reduction, whether that is balanced or not. In KMnO4 case it is balanced, 1 manganese it is balanced. And here in case of iron, there is 1 iron and here it is 2 iron. Therefore write here 2, it is balanced. In case of KMnO4, it changes from +7 to +2. Hence, we can say that it is gaining 5 electrons. Okay, gain of 5 electrons happens here in case of KMnO4. Include that 5 electrons are gained during this reaction. But in case of iron, iron changes from +2 to +3. It is losing 1 electron, but as there are 2 iron atoms, it is losing 2 electrons. There are gain of 5 electrons, loss of 2 electrons. This is not really possible because the number of electrons lost and gained should be equal. Hence, this equation, the first equation and the second equation, the first equation multiply that by 2, number 2, and the second equation multiply it by 5 so that the number of electrons lost and gained will be same. After multiplying we will get 2 KMnO4 plus 10 electrons which gives rise to 2 MnSO4, right? Next, in this case we will get 5 2s are 10 FeSO4 which gives rise to 5 Fe2SO4 thrice plus 5 2s are 10 electrons. Later we have to merge both the equations. Okay, write all the reactants on the reactant side and products on the product side. And while writing, we can immediately cancel. There are 10 electrons which are lost and 10 electrons which are gained. We can cancel that first only. Okay. 2KMnO4 2KMnO4 combines with the 10 FeSO4, and along with that we have one more reagent, which is sulfuric acid, H2SO4. Okay, which gives rise to the products are 2MnSO4 plus 5Fe2SO4 thrice plus K2SO4 plus H2O. Okay, after all this, now we will identify whether all the elements are balanced one by one. Before we balance all the elements, first we need to check whether all the elements are balanced, right? First, we have to check all the elements apart from hydrogen and oxygen. Once all the elements are balanced, hydrogen and oxygen should be balanced by adding the required number of water molecules. Okay. First, let us check each and every element. First is manganese. 2 manganese, 2 manganese. Yes, it is balanced. Next comes iron. There are 10 iron atoms on the reactant side. 5 2s are 10 on product side. Yes, that is also balanced. Next comes here potassium. There are 2 potassium on product side and reactant side. That is also balanced. Yes. When it comes to sulfur, in the reactant side we have 10 plus 1 11 sulfur atoms, and on the product side we have 2 plus 5 3s are 15, 15 plus 2 17, 17 plus 1 18. 18 sulfur atoms on the product side. Hence, now I will add a stoichiometric coefficient 8, so that 10 plus 8 18. 18 18 right now sulfur atom is also balanced. Okay. Now the remaining elements are hydrogen and oxygen. 8 2s are 16 hydrogen, right? And on the product side I will write 8 here. 8 2s are 16. Hydrogen atom is also balanced. After this, the oxygen atom which is left over, by default it will be balanced. By default oxygen atom will be balanced. You can check it out. Okay, hence the balanced reaction will be 2KMnO4 plus 10 FeSO4 plus 8 H2SO4, which gives rise to 2MnSO4 plus 5 Fe2SO4 thrice plus K2SO4 plus 8 H2O. And this method of balancing redox reaction, we call it as balancing of redox reactions by oxidation number method. This is there in NCERT textbook as well, very important for your board exam, and these stoichiometric values will be asked in competitive exams like KCET and NEET. Okay, hope this balancing is understood to you. To understand more concepts related to balancing of redox reactions, please do follow our channel Vidyavardhini Academy. Thank you.